Okay, I'm back now. So all what I have to remember out of this is that cosine is an even function, which means cosine absorbs the negative and of course the cofunction, and everything else is odd. And that saves me a lot of work on graphing. I'll tell you what that means when we get there. For now, if I want to follow the trend, I could do this two ways. One way, I could say, look, the reference angle is 30 degrees. What's the cosine of 30 degrees? Cosine of 30 degrees is the adjacent over the hypotenuse. It's radical 3 over 2. Done. The question is it positive or negative? You could say, rotate negative 30 degrees. All students take cosine is positive. Done. That's one way. I really don't need to use this, and just to demonstrate negative 135, I could say negative 135, there's negative 135, you have a reference angle of 45 degrees. Well, I know that's radical 2 over 2, and all students in this quadrant sine is negative, and I'm done. So I could really use what I used in the beginning of this section and derive all of those. I do want to use the fact that even odd just to demonstrate and learn. Keep in mind, if the angle is positive, that doesn't mean that cosine of that is positive or negative. If the angle is negative, that doesn't mean anything. What matters is which quadrant does that fall under, and that tells you whether you have a positive or a negative. So let me make use of this. Cosine is the even function. So this is the cosine of 30 degrees. It absorbs a negative. I know the reference is 30 degrees. That's, what do you say? Radical 3 over 2. And in quadrant 1, we're all positive. This is negative the sine of 135 degrees. This is negative, and 135 degrees has a reference angle of what? 45 degrees. That's radical 2 over 2. All students take calculus, and in this quadrant we have a positive. Negative times a positive is a negative. Cosecant is 1 over the sine, and sine is odd. So this is 1 over negative. What's the sine of 30? Sine of 30 degrees is the opposite over the hypotenuse. So that's actually negative 2. This is the same as the cosine of 270 degrees. 270 degrees is a special angle. You're right there. And cosine is a 0. Hopefully we're getting that. And you should be this comfortable with this. How about 70? This is the sine of pi over 3. Well, that's negative. So that's negative, and the sine of pi over 3. Pi over 3, I cluttered this. Let me just clear it out a bit. Pi over 3 is right there, and sine is the opposite over the hypotenuse, or it's right there. Wait, time out. Yeah, it's right there, and sine is the y. This is negative the sine of 3 pi over 2. Negative 3 pi over 2 is right there. Sine is negative 1. The triangles can't help you on those. It has to be the trig. So that's a positive 1. This is 1 over the cosine of pi because cosine absorbs the negative. And pi is right there. Cosine is a negative 1. This is, so I could say, since this is associated with sine, this is negative the cosecant of pi over 3. And pi over 3, either you're looking at this angle or you're looking at this angle. That's the hypotenuse over the opposite. Hypotenuse over the opposite. Right, you could rationalize that. Again, on an exam, you don't have to. And isn't this negative the sine? One sec. And we're looking at 78, 78, and are those angles the same? They are. So what is it? It was sine squared of an angle plus cosine squared of an angle equal 1. If I want a secant, I'm going to divide this by sine, by cosine. 1 over cosine is the secant, cosine squared. Cosine squared over cosine squared is 1, and sine over cosine is the tangent. So wouldn't you say this right here is the tangent squared of 18 degrees plus 1? Minus tangent of 18 degrees. And what would that be? Wouldn't these two cancel out? And you're left with a 1. One thing I want you to know. Tangent is unique. If I take 390 degrees, I could subtract 360 degrees. This is coterminal, which means the sine of this angle is the sine of this angle, cosine match, and tangent match. Now, tangent repeats every 360, but tangent is a special case because tangent repeats every 180 degrees. So with tangents and cotangents only, if you have an angle and you subtract not 360, 180, that will still be coterminal, which means I could say this is the tangent of, and instead of subtracting 360, I could take 180 out of an angle. The values of the tangent will be identical. And this isn't that 1 over the tangent, oops, isn't that 1 over the cotangent of 20? Wouldn't that be a 1? And there's your homework. Oh, I left 2 problems out.